Uh, are we live? Um, Let me see. All right. Uh, are we live? Um, Let me see. All right. Okay. Uh, yeah. Can everyone see me? All right. All right. So, okay. All right. Hello everyone. How are you guys? And today is our day 9, I believe. Today is our day 9 of our daily coding journey, and today we will be. Today is a revision day as much as tomorrow. Tomorrow, I may not be able to do live stream because of some work. Okay, I will not be able to do live stream, but I'll try to incorporate that on Monday or maybe next Saturday or Sunday. Okay, so I'll try to incorporate that. Coming back to it. Yeah, I believe that's what I wanted to share with you guys. And today we'll be doing some questions. Some questions we will be doing first because that were important, because we have left trees part, and after we finish that, we will be doing revision. Okay, from the arrays part only. Okay, so we will be revising the lead code solutions that we have did. We will revise all the methods we did, and what not to do, what to do. Okay, all those kinds of things we will be doing. Okay, so yeah, that's what I wanted to share with you guys, and I believe we'll be doing okay. Okay, so yeah, that's it. So let me just reduce myself into this. Yep, that's it. All right, and today we'll be doing regarding the status sheet that we were doing. Okay, so we have now few questions left. We have to do ribbon card today. Today we will be also doing integer to Roman, Roman to integer. The we did yesterday Roman to integer. Today we'll be doing integer to Roman. Okay, so that's a good question. And we'll do ribbon card today, boil more today, mobile numeric keypad conversion today. After that, we will be left with remove duplicate, adjacent, recursive, and stack based. After that, we will be doing wildcard. Oh, sorry, we will not do wildcard string matching. It's called DP question. We'll learn DP, and after we'll that too, and then guess the word. Okay. It's like 2 4 questions, and then after that, we can just revise as much as we can. Guess the word. Guess the word. Lead code. Okay. Oh, okay. So this is it. Guess the word. All right, so you are given an array of unique strings words where word size 6 letters long. One word of words was chosen as a secret word. One words of word was chosen as a secret word. You are also given the helper object master. You may call master dot guess word. You should not implement it or speculate about the implementation. Public int guess string. Public int guess. You may call the master.guess word, where word is a 6 letter long string and it must be from words. Master.guess word returns -1 if word is not from words or an integer. representing the number of exact matches, values, and position of your guess to the secret word. There is a parameter of allowed guesses for each test case, where allowed guesses is the maximum number of times you can call master.guess word. And for each test case, you should call master.guess with the secret word without exceeding the maximum number of allowed guesses. You will get either you took too many guesses or you did not find the secret word. If you call master.guess more than allowed guesses times, if you do not call master.guess with the secret word, you guessed the secret word correctly. If you call the master.guess with the secret uh, with the number of calls, master.guess is equal to number of allowed guesses. The test case is generated so that you can guess the secret word with a reasonable strategy other than using brute force method. Hmm. Okay. Master.guess A returns 1 because A is not in word. AACK returns 6 because 6 is in secret. And master.guess CC badge returns 3 because CC badge has 3 matches. क्वेश्चन अच्छा है बट ये भी समझ नहीं आ रहा है हमारे मेरे को समझ में नहीं आ रहा ऑलराइट सो let's not I believe let's not just waste time. Let's continue with our study. Okay, so we shall do some questions. For example, this question first, then we'll do ribbon carp and all those questions. And all right, all right, all right. Okay, okay, all right. Yep. Integer to Roman. 7 different symbols represent the Roman values. Okay. Let me just reduce myself. And you should enjoy the music. Ah, okay. Okay. Maybe. All right. लास्ट क्लास में नहीं, लास्ट रिवीजन में हम लोगों ने ये देखा था कि रोमन टू इंटीजर कैसे फॉर्म हो रहा था। तो हम लोग लास्ट में लास्ट में हम लोग वैल्यू को शुरू करते थे, एक प्रीवियस नाम की हमने वैल्यू बना रखी ताकि हम प्रीवियस को चेक कर सके एंड वी वर कंपेयरिंग इट कॉन्टिन्यूसली। तो पहले हमने फॉर एग्जांपल वी चेक्ड वी फर्स्ट, सो वी देन चेक कि क्या वी जो है वो प्रीवियस छोटा है, प्रीवियस तो हमारा 0 था, नहीं था, तो हमने क्या करा था, रिजल्ट के अंदर ऐड कर दिया था। एंड देन प्रीवियस हमारा क्या 5 बन गया था, देन वी चेक 1, देन वी चेक C, M एंड ऑल टुगेदर थिंग्स, देन वी फॉर्म द वैल्यू ऑफ द रोमन इंटीजर। नाउ दिस क्वेश्चन इज आस्किंग कि आपको इंटीजर दे रखा है एंड यू हैव टू फिगर आउट कि यू नो व्हाट काइंड ऑफ वैल्यू वुड दैट फॉर्म। ओके, सो नाउ यू हैव टू अंडरस्टैंड वन थिंग वेरी केयरफुली। ऑलराइट, 1 से नम हो सकता है 4000 के बीच। Now you have to understand one thing very carefully. How are we going to determine कि for example अगर कोई वैल्यू दे रखी हो आपको 3749, ओके, टेस्ट केस भी है अपना, ठीक है। तो 3749 एक्चुअली बनता किससे, हमारे बनता है 3000 से, देन वी हैव 700, देन वी have a 40 and then we have what, then we have a 9. All right, so we have 3000 and 700, then we have 40 and then we have a 9. Okay, so how are we going to determine that you know what, you can actually use this. So for that, for determining a particular range of values कि उस पे कौन सी वैल्यू आ रही है, I think we have to look at and we have to break that number into basically parts of the tens and thousands. All right, so how are we going to do that? How can we break a number into this particular thing? Okay, so for example, if we have another case, for example this 58, okay, so 58 वाले केस में हम लोग क्या कर रहे थे, 58 वाले केस में कर रहे थे 50 plus 8, and if it was a Roman number, so Roman number में हम इसे कैसे लिख रहे थे, LV and then we I. Okay, so we were doing this, but we were what, traversing from the behind, and this one is same and this one is same and this one is 3, and then you know what, 3 plus 5 is equal to 8 and 8 plus 50 is equal to 58. So we were doing this. But how can we determine from 8 and 50? Look, you cannot do that from backwards now, because backward वाले position में 8 के लिए हमारे पास number नहीं दे रखा. Okay, we don't have any number of 8. We can break 8 into 5 plus 3, but this is not the case right now that we are really seeking. What we can do is we can figure out from the first part. आगे से देख सकते हैं, बट हमें ये पता लगाना पड़ेगा पहले कि इंटीजर की लेंथ कौन सी है, एंड इफ वी फाइंड आउट द लेंथ ऑफ इट देन वी कैन एक्चुअली एक्सट्रैक्ट वैल्यूज आउट ऑफ इट, right? For example, the length of here is 2. For example, the length of here is 2. Now if I find the length of here is 2, okay, so the first number has to be starting from maybe L, because L से वो छोटा हो नहीं सकता, number L से छोटा तो हो ही नहीं सकता. So what I did is I did L. Okay, alright, and then I find कि I have like 50 I have added now. I have the number 50 with me now. Rest में से मैंने 50 को minus करा, then I have 8. And what can be 8 driven down into? I cannot add x here. I cannot add x here. So so the bigger value is L, and I have to add a smaller value inside it. Okay, so what the smaller value can be added inside it? So for suppose you can add, so what are the options for the smaller values? I can add x here, I can add v here, and I can add 1 here. This is the smaller values option that we can here. But should we use x here? X is what? 10. Alright, but we have to find the value which is less than 8, because that is the value here. So we have to find the value that is less than 8, and the value less than 8, and then first digit is what? V. So we have to pick elements out of it for which the tens digit, hundreds digit, and thousand digit is was same. This is the main case here. Alright, let's try to do it. This will be formed. Now int result is what? Int result is going to be integer dot parsing s dot substring s dot length s dot, or just simply s. So int result is going to be what? Integer dot parsing 58. Now this is the result. Okay, and once we find out that integer has basically turned to 0, we can do that. Okay, so and the good thing is you can, so let's try to build a string. So we'll build a string to be for string builder, and we call it Roman, because this is the final list we are going to be making, and the result is going to be what? 50. Alright, so 50 is going to be the result. Okay, and our goal is to reduce result to 0. Reduce result to 0. Goal is reduce result to 0. Okay. How we gonna do this? For example, let's see one thing. Let's see some properties of Java in some good sense. Okay, so let me go to my Java compiler. Go to my Java. Let's see some properties of Java. Let's keep this, and suppose I do 3749 3749 and I divide it by 10. What should it give me? It should give me 9. Giving me point, and this 9 is given me what? This 9 is given me the remainder or the last digit out of it. Okay, it is giving me the last digit out of it, but this is not what I want. This is not what I want. So how am I going to form this value now? So for suppose I do this, I divide it by 10, then what is going to give me? It's giving me 374. So now it's giving me the front values out of it, and it's removing the values out of it. Okay. So the only crux that I have to find in this situation is how would I traverse this from this part. Alright. So this is the main crux. Let's see. let's see. S dot length is actually pretty useless here because we have to traverse here from this to this, but the result, yes, so we have to find out from 50. Okay, so suppose if we have the number of 5460 something, how are you going to determine that this is going to be the only value regarding that? We can do this by and we return result. No, we don't want to return result. Public int. There's an int array. Yeah, we have to return the string. No? So I don't think we should do this. Then we have Roman. Alright. And then there will be case here, but actually you cannot do this. So I would be saying, you know what, I can do this that as well. So never queried. Alright. क्वेरी नहीं करी हमने कभी, क्वेरी करेंगे तो कोई इतना बड़ा मसला नहीं है. Roman dot toast. Alright. So we have Roman here. Then okay, so we have the return type set for us as well. Now how are we going to determine that? This is the main crux, right? This is the main very crux. How are we going to determine everything? We can use we can use the length of the array. Okay, we can use the length of the array. So if maybe s dot length is for 2, then I have known that you know what you can do basically. If map dot get is equal to maybe 2, then you know what, you can do that. Okay, so alright, so how are we going to do this? It's a good question. Okay, so how are we going to do this? Good one. Today I'm feeling very sleepy. I don't know why. Okay, so I think 1, 4, 5, 9, 10, 40, 50, 90, 100, 400, 500. I think these values are enough for now. And then we can do what? You can, alright, so we can for int val to map dot key set map dot key set. Now while result is greater than val, then जब तक हमारी रिजल्ट जो है वो वैल से बड़ी है, वैल क्या है, वैल तो हमारी इंडेक्स आइडेंटिटी है, तो जब तक हमारी जो रिजल्ट है वो वैल से बड़ी रहेगी तब तक मुझे क्या करना है, रोमन में अपेंड करना है मैप डॉट गेट वैल एंड रिजल्ट में से माइनस कर देना। देन इफ वी सी हियर Let's see. So we have 58 here. Then we have what is the US is equal to 58 here. So the map with the result हमारा result is greater than val. तो मैं वैल्यू कुछ और लेनी पड़ेगी, चेक करनी पड़ेगी हमें। ओके, ये चेक करना एल डाल दी। ओके, 8 ग्रेटर देन x आएगा 10 फाइनल रिजल्ट इज ग्रेटर देन 10 छोटा है, then we have 8 छोटा है, then we have 5 value 5। It's showing it's a slow solution. Let's see the time complexity. The time complexity is big over 1. Wow. Space complexity is big. There's some problem in this. There's some big problem in this. It's a good solution यार, पर क्यों नहीं मान रहा? देखो वो तो बिगो पेन और बिगो 1 कह रहा है। ओके, तो ये क्या कर रहा है कि इसने इसे मैप कर दिया है, एक रोमन बनाती है, इसकी एक गम वैल्यू बनाती है। फिल्टर ऐसे कर रखी है अपना, मुझे को तुझे ब्रेक कर देना, फिर इसमें ये बेस केस कर दूँ, और जब तक नम मेरा नम से 5 से बड़ा रहेगा, जीरो डिपेंड कर देना, मैंने तो माइनस कर देना। हाँ, तो वही तो कर रहे हैं। dot append the Romans of I, and num is equal to num minus nums of I as we dot translate. हाँ तो बस ये array यूज करके इसे फास्ट कर रहे हैं. सारे सोल्यूशन देखो एक जैसे ही होंगे. ये देखो, ये देखो, सब एक जैसे. ओके. और ये फ्रंट वाले तो एक नंबर के कुत्ते होते हैं भाई. ये यूं डाल देते हैं बस स्टैटिक फंक्शन ये करके और डिस्प्ले रन टाइम डॉट टेक्स्ट. यार हम भी यही करते हैं. इसे मैं पेस्ट कर लेते हैं. पेस्ट करेंगे. ऑलराइट, अभी नहीं कर पा रहा. ओके, तो इसे अच्छा क्वेश्चन था. ऑलराइट, so we did this. Okay. Okay, so this question is remove all adjacent duplicates plus print. Yeah, we were seeing this yesterday. और इसमें हमने दो तरीके हम सोच रहे थे. ये वाला कि या तो हम इस क्वेश्चन को स्टैक से करेंगे एंड if not stack then we can create I think stack से ही होगा यार. और कैसे होगा ये क्वेश्चन? और कैसे होगा? recursive या stack based? So we have to use recursion in this. So but how we will find recursion? So every time we find something out of it, then we can continue ahead in this and yeah, I mean. रुको यार, कौन सा डाल दिया मैंने? रिमूव डुप्लीकेट लेटर्स। अरे करा तो मैंने वही है, वही मैंने सॉल्व करा था। कौन सा कर दिया मैंने? मैंने यही क्वेश्चन का कोड कहीं और यूज कर रखा है, तो इट विल वर्क। लेट्स सी। ये वो वाला कोड था ना जिसमें हम कर रहे थे, what was that? Lexicography. We were doing it, right? And this was what, this was the, you know, this was, yeah, this was a lexicography question. Yeah, this was a lexicography question. Let's see what. Yeah, yeah, this is a lexicography question. Good one. हमें सारे डुप्लीकेट्स निकाल देने हैं इसमें, ये है वो। Okay. हाँ, ये वो क्वेश्चन है। आई थिंक वी, हमने किसी और का क्वेश्चन कहीं और कर दिया। रिमूव एडजेसेंट डुप्लीकेट जीरा, ये स्टैक का क्वेश्चन था। ऑलराइट, सो दिस वाज अ स्टैक बेस्ड क्वेश्चन। वही सोच रहा था, कुछ तो हमने गड़बड़ कर दी इसके अंदर। लेक्सियोग्राफी वाला क्वेश्चन था, एंड वी वर यूजिंग मोनोटोनिक स्टैक देयर। ओके, सो या लेट्स सी दिस। static public remove duplicates. Yep. All right. So cow duplicates and so baka. All right. So string builder is equal to string builder and return. ऑर्डर क्या मैटर करता है इस क्वेश्चन में, ये सवाल है सबसे बड़ा। एंड आई डोंट थिंक इसमें ऑर्डर मैटर करता है। व्हाई? बिकॉज मुझे तो केवल रिमूव करनी है यार वैल्यू। तो मैं क्या कर सकता हूँ, मैं तो मैं एक स्टैक बनाऊंगा, एक प्यारा सा स्टैक बनाऊंगा, सारे स्टैक में कैरेक्टर रहेंगे मेरे, और अब मैं यहाँ से वैल्यू डालना शुरू करूंगा। यार इतना मुश्किल क्वेश्चन है नहीं है वैसे। ओके, मुझे केवल ये चेक करना है कि क्या मेरी स्टैक में आने वाली जो वैल्यूज हैं वो हो पा रही है या नहीं। एंड इफ दे आर नॉट, एंड आई वुड, देन आई वुड रिटर्न बेसिकली पॉप। हाउ वुड आई पॉप? I think for int j is equal to 2, for example, I'll run a loop from 2 and then I'll pop the values out of it. Okay, because I have to remove ऑलराइट, अगर मेरा स्टैक एम्प्टी नहीं है तो मैं क्या करूंगा? तो मैं स्टैक में से पॉप करूंगा, पर मुझे स्टैक में से कितना पॉप करना है ये भी तो क्वेश्चन है यार। अगर मेरा स्टैक एम्प्टी नहीं है, फॉर एग्जांपल अगर क्वेश्चन हो ए और ए, तो मैं स्टैक में से पॉप कर दूंगा। ऑलराइट, अब एल्स स्टैक में पुश कर दूंगा। ऑलराइट, एंड हाउ वुड आई, हाउ वुड आई, सो फॉर कैरेक्टर कैर सी टू स्टैक, तो मैं क्या करूंगा? sb डॉट अपेंड सी कर दूंगा, एंड देन आई रिटर्न इट। ऑल्दो आई कैन रिटर्न इट यूजिंग अ रिवर्स फंक्शन, बट लेट्स सी। या सी, इट्स सो सिंपल। I don't think what was more difficult in this. See some edge cases here. Edge cases क्या हो सकते हैं? Edge cases मैं बताता हूँ क्या हो सकते हैं कि अगर s dot length ऑलरेडी वन हो तो आपको क्या करना है यार? तो क्या करना है? तो रिटर्न कर देना, तो रिटर्न सेम एस कर देना। कुछ करने की जरूरत ही नहीं है, कुछ करने की जरूरत ही नहीं है, एंड दैट्स व्हाई सॉल्व। यप, ऑलराइट, so it's simple one. Alright, good one. अब एक कैरेक्टर डाला, अब चेक करा बी को। नाउ हम बी में ही चेक करेंगे कि क्या मेरी स्टैक की जो पीक वैल्यू है क्या वो उसके बराबर है या नहीं है। मैं कहूंगा जी नहीं है। यहाँ पे देखो स्टैक की साइज देखो, स्टैक के अंदर भी केवल ए है। मैं कहूंगा जी है या नहीं है, मैं कहूंगा जी नहीं है, तो वो स्टैक के अंदर पुश कर देगा। पुश करने के बाद दोबारा चेक करेगा। अब यहाँ पे केस आएगा बढ़िया सा, देखो अब स्टैक के अंदर वैल्यूज हैं ए और बी, ये बी टॉप में है, ये उल्टा कर रखा है इसमें। एक सेकंड, ये है स्टैक की टॉप वैल्यू, यहाँ से देखो बी अंदर आ चुकी है। अब इसके अंदर हम नीचे गए, अब चेक करेगा बी 2 पे, अब वो चेक करेगा, देखो ये वैल्यू ट्रू हो चुकी है। अब स्टैक एम्प्टी नहीं है, स्टैक की जो वैल्यू है ये इसके बराबर है। तो अब मैं क्या करूंगा? स्टैक में से पॉप कर दूंगा। मैंने कुछ डाला नहीं है, मैंने स्टैक में से पॉप कर दिया। अब साइज का 1 बच जाएगा, एंड देयरफॉर इट विल बी एबल टू चेक ग्रीडीली। अब चेक करेगा इसके अंदर सीधा ए आया है मेरे अंदर, तो वो कहेगा जी हाँ मुझे ए दिख गया है, बढ़िया दिख गया है मुझे। तो अब दोबारा चेक करेगा तो यहाँ पे स्टैक की वैल्यू पॉप हो गई है। तो स्टैक की वैल्यू यहाँ पे ए थी, इसके अंदर वापस ए आएगी और इस स्टैक की जो वैल्यू है वो वापस एम्प्टी हो जाएगी। अब स्टैक की वैल्यू 0 हो चुकी है। अब दोबारा से वैल्यू डालेगा तो वैल्यू कौन कौन सी बचेंगी? लास्ट में सी और ए बचेगी। ठीक है, तो ये इंट्यूटिव क्वेश्चन था, ये सिमुलेशन वाले क्वेश्चन होते हैं। गुड वन, सिंपल था, अच्छा क्वेश्चन था। ऑलराइट, एक चीज और चाहता हूँ, और अगर मैं इसे केवल एक सिंपल एज केस को हटा देता तो क्या ये सॉल्व कर पाता? तब भी कर लेगा। बट अच्छा करा कि डाल दिया, कभी कभी डाल देना चाहिए, ऐसे हटाना नहीं चाहिए। चलो बहुत बढ़िया। हम्म। Okay. Okay. Letter combinations of phone number given a string containing 2 to 9 inclusive written all possible letter combinations that are number to be present in the last of the often happen with digits from the zero to but does not have many decimal. ये क्या है? First repeated word. ये हमने करा नहीं था? First repeated word. First repeated word. First repeated word. Okay, what was it? All right. All right. Let's do. What was that question? Mobile number. Mobile. Keypad conversion. All right. And we have GHI and JKL. Suppose we have this. Now, how would you map these? Now, A will be mapped to A will be mapped to B. No, they will be all unique combinations. Okay. So A will be mapped A, D, E, F, G, H, I. Okay. So A will be mapped to what? A will be mapped to D, E, F, G, H, I, and J, K, L. Alright. Suppose we do this. Okay. Suppose we do 2, 3, 4, 5. We have a digit from 2, 3, 2, 4, 5. 2, 3, 4, 5. Okay. Let's do 2, 3, 4, 5. Okay. Let's do 2, 3, 4, 5. And we do what? List of thing called list, and then we return, and then we call return list. Then we return list. Okay. Let's do this. I want to see what the results are in order. So that will give you a very good order. Very good understanding. Okay. Let's run this. I know. What I want to show you guys is, see, this is the one. So if you have this here, then what would happen? ADEF A. So for example, it would be ADGJ, ADGJ. Then what? ADGJK, ADGJ. This A here, then D here, then G here, then J here. Next value would be what? ADJK. Then what? ADGL. Now JKL is finished. Now let's move to GHI. What would be the values here? ADGH. This is how you're gonna fill all values. Now the question is, how you're gonna map these characters into one? How are you gonna map these characters into one? This is a very good question, okay? This is a very good question. Suppose we do for 2. Okay, now we have to make a hash map also. I think we forgot to make a hash map, because we have to make a hash map. Map. Character. Map. And we have to make character. We don't have to make a character as well. करेक्टर का बना है, किस किस का बना है, मैप कैसे बना है इसका? Because we have A, B, then D, E, then G, E, F. So, for example, we have strings of A, B, C, and D, E, F, and we have to then traverse then from map.getValue. Hmm. So we can make what? 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 You can use a hash table. You can use a hash table. So it is given like a hash table as well. Yeah, you have to use a hash table. How do you use a hash table here? We can let's do what? Let's do, you know what? Let's do one thing. Let's create a string of tables. Let's call them uh, digits array. All right, and this digits array would be containing what? um, ABC, DEF, or you know what? Let's take a linked hash map. Linked hash map. All right. Now this string is what a list of strings, but we don't want to take a list of strings here. We just want to take integers here. Should we do integers here? Yes, we should do integers here. So we should do integers here, and then we should use the strings here. String here. And let's now put values. So map.put here is given in the range of only 2 to 9. So we don't have to take care of any 9 or 10. Now we have put all these values. It's a linked hash map. So the values would be arranged inside the order of its addition. Now we shall create a new function, and let's name it private static private, and we call it static private. We call it let's call it static private. We call it void function. No, let's not call it void function. Let's call it a list of integers. List of integers. List of integers. And list of string. List of strings. And we shall call it backtrack. Backtrack. And what do backtrack would contain? So backtrack would be having the string of digits. Backtrack would also have map of string of map of integer map of integer or should I say linked hash map. Okay, and we call it from integer string to string, we call it map, and it also would contain an int of index because we have to traverse it from index every time. Then what we have the list of strings here. Now list of string will also we will adding the list of strings inside the list of string. Okay, so it's like doing things one more time. Okay, now we have this. So let's call void for now. Let's do not call anything now. Yep, let's call void for now, and let's just first run it. Okay. Char c is equal to map dot get digits dot char I at char of 0, and you know what, you can just add list dot add c digits dot char at I. Digits dot char at I map dot digits dot char at I at digits dot char at I map dot digits dot char at I at char is equal to 0 at char at I. Alright, so this is what working should be, and this would add cannot invoke char c char c digits dot char at Hmm. All right. Let's see. अभी के लिए हटाते हैं इसे। हाँ, हम कहाँ थे? यहाँ थे। तो इंडेक्स होगा, लिस्ट होगी इस चीज की। नाउ इंडेक्स होगा मेरा ओरिजिनल स्ट्रिंग पे। नाउ इफ आई ट्रेवर्स दिस इंडेक्स, हम नेक्स्ट वैल्यू पे डाल देंगे। ऑलराइट। छोड़ो इसे। स्ट्रिंग ऑफ कीपैड बनाते हैं। उसमें हम क्या वैल्यू डालेंगे? सारी स्ट्रिंग डालेंगे। सारी स्ट्रिंग डालेंगे उसके अंदर वैल्यू डालें। एंड वी विल हैव दिस हियर। अब बनाएंगे वैल्यू बढ़िया सी। देन वी हैव ABC here, and then we have DEF here, DEF here. We have GHI, JKL, DAF, GHI, JKL, MNO, PQRS, and then we have DUV, and then we have WXY. So this is what 0, 1, 2, 3, 4, 5, 6, 7. Okay. ये ठीक है। अब वैल्यू कुछ भी है बाहर में जो, ठीक है। और तो वैल्यू आएगी नहीं, बट ये इंडेक्स कर देंगे फिर। यस, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. ओके, these are what now indices now. what shall we do now? What shall we do now? So, all right, all right, and we back the string value of strings. All right. So the question is how we're going to make it. So first of all, we're going to make an array list. We will name it what? We will name it string, and we will name it res, and res is equal to new array list, and res dot add res dot add list. List is going to add these values. Okay. So list is what? Empty right now. What is the problem? Show the problem and return res. Okay. We are also going to create a string builder, and this string builder sb is equal to new string builder. All right. So this is what happens. Now let's see what is the problem going on here. Okay. Res dot add. Add cannot be applied to util Java functions. Okay. So sb. Yes. Add java.lang in string in java.util list of string of list. डायरेक्ट स्ट्रिंग में डाल देंगे। चलो शुरू करते हैं। All right, let's start. Okay. Okay. So okay, let's start with the building of it. Okay, so if index is equal to digits dot length, then you know what you can do, list dot add keypad dot index. Okay, so ये हमारा बेस केस हो जाएगा। जैसे ही हमारी ये सारी वैल्यूज हम लिस्ट के अंदर कीपैड डॉट इंडेक्स की सारी वैल्यूज को हम डाल देंगे। कीपैड डॉट इंडेक्स की जितनी वैल्यू होगी, बट टेक्निकली कीपैड डॉट इंडेक्स की सारी वैल्यू में नहीं डालनी। लेट्स सी। how can we do it? Backtrack. For example, if we start from making it from C, then A से हमने वैल्यू डाली हमने D E F and after it we backtrack it, we index press 1 हमने करा इसके अंदर and then we add what B into D into F DEF, then we backtrack it from like C dot, तो हमें index plus 1 करते जानी तो हमें digits dot then तक हम ना पहुंच जाए। तो देन हम कीपैड की सारी वैल्यू डाल देंगे इसके अंदर। प्रिंट लेटर इज इक्वल टू कीपैड ऑफ डिजिट -0। Why? Because for int I is equal to 0, char C is equal to digits dot caret I and alright, so sb dot append letter, so ऑलराइट। तो अब मुझे लेटर में से वैल्यू को डालना है, मैं कैसे डालूँ? एग्जाम्पल इफ आई गेट स्ट्रिंग लेटर में मुझे वैल्यू मिली व्हाट, स्ट्रिंग लेटर में मुझे वैल्यू मिली 2, then I have to append this 2 inside that. So how am I gonna do it? So string digits, it's equal to, you know what, I have to create a list and then add something also, backtrack index plus 1 and list.st.to string. Okay, all right, is never used because अब use होएगा ना वो, and return backtrack, and backtrack के अंदर string भी थे, उसमें आएंगी एक digits and we have keypad and 0. Let's run this. Alright, how am I gonna do it? How am I gonna do it? How am I gonna do it? Do it, do it, do it, do it. Return list. How am I gonna do it, do it, do it, do it, do it, do it, do it. For example, if I add 2, 3 here, then you know what, do it, do it, do it. A B C, A B C, D E F, A B C, A B C, D E F. Here, C is equal to letter dot caret O नहीं, letter dot caret I index. C dot append letter, backtrack digits keypad index plus 1. C dot append S dot append C, alright, and backtrack digits keypad and index plus 1. A and AD, A comma B, A comma C, A comma D, then index. Okay, then मुझे index को plus plus भी करते रहना है. All right, so there is some problem here. प्लस प्लस करना है, बैकट्रैक डिजिट्स कीपैड पाथ एंड लिस्ट एंड रिजल्ट। ऑलराइट, पागल हो गया यार ये। ऑलराइट, एंड देन आफ्टर वी आर टिक पाथ फिर से डिलीट क्या है, पाथ डॉट लेंथ -1। अच्छा ओके, फिर देन बैकट्रैक में क्या करना है, डिजिट्स है, कीपैड है, इंडेक्स जीरो है, स्ट्रिंग बिल्डर है, न्यू स्ट्रिंग बिल्डर एंड रिजल्ट। तो इसमें गड़बड़ क्या हो रही है, एक मिनट, क्या गड़बड़ हो रही है, वॉइड। अच्छा अच्छा अच्छा, वॉइड है ना, वॉइड सबमिटर कर ली इसको। हाँ तो ठीक है, तो यहाँ से हम करेंगे इसे एंड देन वी रिटर्न रिजल्ट। ऑलराइट, ए डी ए एफ बी एफ वी एफ डी एफ सी एफ ऑल दो सब काइंड थिंग्स हमने कर दी। एंड बट अगर वैल्यू 3 हो तो क्या करेंगे, तो डी ई एफ डाल देंगे। ओके, तो गुड। ऑलराइट, चलिए, अब हमें 2-3 एल्गोरिदम्स करनी है। इन एल्गोरिदम्स में कोड पहले तो कुछ नहीं करेंगे थोड़ी देर के लिए, ठीक है? इनका कोड समझते हैं, क्यों ये 3 एल्गोरिदम्स मेन यूज़ हैं। पहले हम रेवन कार्व देखेंगे, फिर केएनपी देखेंगे, फिर वॉइस मोड देखेंगे, ठीक है? एंड वी डिड दिस आल्सो। And after we do this, these Raven कार्व, no, we did not do Raven कार्व। इन 3 एल्गोरिथम्स को पढ़ेंगे पहले, क्या होती है ये। इन एल्गोरिथम्स को पढ़ने के बाद हमारे पास एक क्वेश्चन बचेगा, गेस द वर्ड। मुझे ये क्वेश्चन समझ में नहीं आया टू बी ऑनेस्ट, तो हम एक बार देख लेते हैं क्वेश्चन है क्या ये। आई थिंक कि कॉलिंग क्वेश्चन है बस बेसिकली, कि आई थिंक मे बी वांट टू चेक कि does this value exist in this or not, okay? So we'll do this, but first we'll do the algorithms first. Algorithms are very important, okay? रिकॉर्डिंग के आंसर बताइए जरा सबका। right. Okay. Yeah. Okay. Okay. And secret around gas and all. Okay. What we have? Secret word, then word, then word. All right. And let's utilize Copilot. Okay. Uh, complete the master function uh, for me, and let's paste the questions over here. All right. Paste the question. And let's all right. जब तक ये वर्क कर रहा है तब तक हम रेवेन कास्ट के बारे में थोड़ा पढ़ लेते हैं। आपको रेवेन कास्ट के बारे में थोड़ा सा पढ़ाया। ऑलराइट। क्या हो गया? बावला क्यों हो गया? अरे ये पूरा कोड क्यों लिख रहा है यार? कौन सा है ये? है ही क्यों? ओके ओके, शिफ्ट हो गया, ठीक है। अभी के लिए काम करेगा, और ये वैसे काम नहीं कर रहा जैसे मुझे चाहिए था। खैर, क्या करें। ऑलराइट, ये लिख रहा है, ये लिख रहा है। Okay, for example, if I take this, ZZ हो रहा है और ये हो रहा है, ये हो रहा है, ZZ हो रहा है, right? And this is the origin, ACCZZ, all right. क्या हो रहा है? स्पीड पे कुछ और कर सकता हूँ, क्या कर सकता हूँ, क्या कर सकता हूँ, क्या कर सकता हूँ, क्या कर सकता हूँ, list of the very what is and for string words to words सारे हमें string words को इसमें word तो ये हमारा हो जाएगा काम, ठीक है। हमें सॉर्ट नहीं करना, सॉर्ट करना, ठीक है। मेरे ओरिजिनल पे एम्प्टी नहीं है तो मैं क्या करूँगा, एक मिनट और मुझे गेस करना है, मैं गेस कैसे करूँगा, मास्टर डॉट गेस फर्स्ट, import master और फर्स्ट और मैं क्या करूँगा इसमें कि अगर मेरी जो फीडबैक है वो 6 है तो मैं क्या कर दूँगा, रिटर्न यहीं पे, मतलब मेरा पहले ही क्या कहेगा मुझे पहला बट अगर नहीं होता तो मैं क्या करूँगा, फिर मुझे चेक करना पड़ेगा, राइट। तो फिर मुझे चेक करना पड़ेगा, तो फिर मैं, क्योंकि मुझे ये स्ट्रिंग हमेशा चेंज करनी पड़ेगी, तो अगर मुझे चेक करना है बार बार ओरिजिनल अगर मुझे मैच काउंट करना है तो मुझे मैच बात करनी पड़ेगी, इसलिए मेरी हेल्प करिए। मैच में मुझे कहेगा कि तेरा वर्ड, अगर तेरा वर्ड और तेरा वर्ड पहला वर्ड है, तेरा वर्ड फर्स्ट, तेरा वर्ड फर्स्ट बराबर है और उसका reference from static constant. Master dot guess is first, तो ये हम नहीं कर सकते. All right. Oh, sorry. So we have to make it master. All right. Okay. Either you took too many guesses or you did not find the secret word expected. You guessed the secret word correctly. Okay. All right. बात करते हैं, इस पे बात करते हैं, ठीक है, देखते हैं इसमें क्या हो रहा है इसमें। अभी के लिए छोड़ते हैं इसे। पहले रेबिन कार खत्म करते हैं, ठीक है, पार्शियल कर देते हैं, पार्शियल कर देते हैं, हैप्पी पार्शियल कर दिया हमने इसे, अभी के लिए वैल्यू हमने डाल दी। अब हम जल्दी से 3 एल्गोरिथम पढ़ लेते हैं बढ़िया बढ़िया सी, ठीक है, जो हमारे लिए इम्पोर्टेंट है, ओके। किसी let's do ribbon carve. I'm very happy. Let's do ribbon carve. Ribbon carve is very good algorithm. And ribbon carve solution is equal to ribbon carve. Let's get it. Let's you know what? Let's start. Raven Karp algorithm index is found at, okay. You know what? Let's leave it blank now. Let's leave it blank. Okay. So you can do Rabin Karp algorithm is equal to new Rabin Karp algorithm, new Karp solution. And yep, okay. So let's write some code here and then we'll see. Okay. पहले मैं आपको बताता हूँ रेबिन कार्प एल्गोरिथम होती क्या है. मैं बहुत ही एक्साइटेड हूँ इस रेबिन कार्प एल्गोरिथम के लिए. ऑल राइट, let me just begin with telling you what रेबिन कार्प एल्गोरिथम is. So रेबिन कार्प एल्गोरिथम is a string matching algorithm which was found by Karp Rabin. Okay. So Karp Rabin in early 90s, he found this algorithm. It is a string matching algorithm which uses hashing technique. So apart from all the string matching techniques that we will see in further videos, जब हम पढ़ेंगे सब सीक्वेंसेस कैसे पता लगाए जाते हैं, जब हम डीपीज का इस्तेमाल करेंगे, हम उससे हेल्प करेंगे, उससे काम लेंगे. रेबिन कार्प एल्गोरिथम is a very crucial algorithm because it helps us to understand how hashing works predominantly in strings. Okay. So when I first learned Rabin Karp algorithm, it was very recently, and this algorithm is basically used to determine, for example, there is a string called job. Okay, there is a string called job, and you have to find inside of the strings. For example, you have to find these strings from example like help me get a job. Now let's see here. Now if I like zoom in here, okay. Now see here, suppose I have to find job inside this help me get a job. What would I do? I would have to like match all these strings, and I have to match this particular mapping until I get, the string value. For example, I would be matching J with what, J with this and this and this and this and this, and if I want like, and if I got J here, then you can use, use what you can then traverse ahead and then find it. But it's a very brutal approach in finding strings where spaces are also included, where characters are also included, and wildcards and all those things. So we can do better than this. Although this is a big of n solution, but we can do also. But we can see there is no best solution present around in every cases. Okay, so even if you got a big of n solution for this particular thing, you can say that, you know what, Lakshya, I can found this particular situation and this and this and this. Then even if you do that, this is not a very good solution. Okay, because uh, for subsequent cases you can find very easily, but not about this. For example, if you are getting on J here and you do not get O here, for example, there is a new word here which is called, maybe you can call A. Now J A is not equal to job, so you will reset back pointers here and then you will traverse ahead and all those things. So it will be not good solution at all. See, there are like 100 ways to do a solution. Okay, you can say that sorting algorithms are like 9 10 algorithms. Okay, there are like 9 10 algorithms of sorting. There is like bubble sort, the quick sort, insertion sort, merge sort, and lots of sorting algorithms we have. But why do we only prefer big of n log n algorithms? Okay, we have merge sort present with us, we have quick sort present with us. Quick sort provides time complexity of n log n, but there are certain cases we have done a hard question on this first missing positive, where we were solving a particular amount of question with a merge sort only. We cannot do that solution with another type of sorting. Only merge sort was the only great solution in that. So the point I'm trying to tell you here is there are multiple ways to particular job, and we have to have that kind of weaponry with ourselves because we have to understand what kind of thing or algorithm this particular thing does. Got my point? So this algorithm, which was found, as I told you earlier, this was found by Karp Rabin. So this was found by Karp Rabin. And this algorithm, the Karp Rabin algorithm, the Rabin Karp algorithm, is used to help find a hash based mapping. hash based matching, not mapping, it's hash based matching. Okay, so what do you mean by hash based mapping? Okay, so the hash based mapping basically says that you create a window of size, the length of the pattern that you want to find. So this is what a pattern, and this is what original string. Okay, so this is the string that you are having, the original string that you have. Now this is what the pattern string, the pattern string length you have to find in this. And every time you travel, so for example, if you see here, for example, you go from H E L. Now this is a pattern length, but you do not find the hash of this hell, HEL, to the job. So what you do is you traverse ahead into the P part. So what you do is you cut the H out of it, and then you add E into it. Oh, sorry, P into it. This P into it, and then you add ELP, and then you add what? Then you add LPM, then you add PME. Okay, then what? GET, and then AJO, AJA, and OB, and all those things. Okay, there's a downside of this algorithm as well. I'll tell you what the downside is. The downside of this particular algorithm is that there are certain cases which are rare cases. But the rare case is what? Let me tell you for something. Let me tell you in the good comments. Okay, there are certain cases. Number one is that hash based matching helps in finding quick intuitions. This is the first point. But there's a problem here. Let me tell you the problem here. The problem is that it is not guaranteed. And I will write it here as well, that sometimes it is not guaranteed here, sometimes, that matched hash value would also mean would also mean the same would also mean the same pattern found would also mean the same pattern found. So this is a very downside of it. I'll tell you why. Suppose there's a job string, for example. Okay, example, job string suppose has a hash key of maybe 234. Suppose, I don't know what the hash key of this is. Okay, and this is what we were finding in this, help me get a job or something. Okay, but instead of B here, instead of O here, sorry, let's say the O here, ABCD, ABCD, MNOP, OP. So I'll add P here, and then I add A here. So P exceeds of O, so this is +1. Okay, and B and A decreases for one of B, so this is A. So JPA also has the same value of 234. All right. So what I was saying is that JPA also has a value of 234. And according to the Rabin curve, if your hash value is same, then what you have to do? You have to basically match all these strings. Then you have to return the answer. But if you have a string of job in pattern, but you are getting returned as JPA, then it is wrong. Then how would you save this? So what you can do is, in order to save yourself from the from the sorry from the above problem, we need to match the string found. We need to match the string found with the pattern. And what it is called? It is called twice verification. And I will write another bracket here again, which was same as Boyer Moore. Boyer Moore algorithm. If you remember it very correctly, the candidate solution one, Boyer Moore algorithm. Getting my point? Are you all getting my point? Okay. So we will create a hash function, original hash function. Then we will create a new hash function. And after we create the new hash function, we will match the hash function keys, and then we will run in the Rabin-Karp solution algorithm. Okay, so there will be three solutions here. Let me just create a something called new hash solution. So we'll create a public int, and we will name this. We will name this. What we will name this? We will name this hash code. Hash code, and this will be creating a string uh, pattern. Getting my point? Are you all getting my point? Now this will be creating a hash code. First, in order to create the hash code value, we will also have to create a constant value, okay, which is the hash code value. So in order to create the hash code value, we'll create a you know a final value of hash key. Okay, so we will create a private final int, and the name of this key would be hash key, and this hash key would be equal to, let's say, what do we name this value? Okay, so let's name this value maybe 10200. All right, something like that. We'll change this. I don't know what the correct value of hash key here is, but we'll just name it. Okay, something like that. So this private final int hash key is equal to this. Okay, so this is the constant value. We'll not change this at all. You cannot modify this as you cannot modify this at all as well. Okay, so you cannot modify this. I'll tell you why. So suppose if you do hash key, yeah, see the problem here. Cannot find the local variable hash key. I think we were doing just final variable. So in order to do this, we will just have to do the public variable. Okay. So I think it now works. So if I do a hash key called maybe not hash key this, and if I call this maybe 2220. So see the value. This is not available. All right. Why? Because you cannot change the you cannot change the final variable. All right, so this is what we have found till now. Let us see something more interesting. Okay, now let's create the hash code key. So how do we create the hash code key of it? Okay, so this is a good question. This is a good question that you want to find. So for um, for int I is equal to 0 and your I is equal to less than, then what? Pattern dot length. Pattern dot length, and pattern dot length is what is going to be in a smaller one. Okay, we don't want it to bigger one cases. Okay, yeah, all right. So for the pattern length, so what you have to do right now? Okay, so your char c is what pattern dot caret I, and you have to create the hash code key. Okay, so the hash code key for this would be, so I'll tell you that if int let's say long here. So long hash is equal to no long int में बहुत value आ जाएंगी. Int hash is equal to 0. Patterns cannot be that greater than. तो hash क्या होगा? Hash होगा hash plus c into math dot power math dot pow. Yep, math dot pow. Your hash code, not hash code, hash key into c. All right. Oh, okay. Math dot pow. Oh, जरूरी होता है ये. So I'll just create the index, public final double key. Okay, so let's do int, and let's do int. All right, this works. What is asking us that you cannot do what? Required type int, provided double, cast expression to int. All right. Okay, so this is useless here then, because you have casted everything out of it. Okay, so this is what here. Okay, from 0 to 1, and I should be adding c here, because we are doing it c here, that is the pattern dot caret I. Okay, so for every c pattern we are creating the hash key, and what is the hash key here? That is the hash key of math dot pow hash dot key. Hash key जो हमने बनाई है यहाँ पे is hash key and by c. So this is what the hash key value is. Okay, so once we created the hash key, we have the pattern length of hash key here. Okay, and after we do string object patterns length, then we will match this hash key particularly out of it. Okay, so this hash key is basically created for everything. Okay, so it will be useful for pattern matching as well. So let's do, and then we'll return the hash key as well. Okay, let's create another function. Let's create another function, private int. Let's name this slide hash, sliding window hash. Now this will be having a sliding window pattern. So this will be having a string of original, original, all right, and string of pattern for now. And it will be okay. So now not this, but this. Okay, all right. And it's saying us that you have to determine the value of it. So I'll just return. So you can just return the new hash value, new hash, return new hash. Okay, we haven't created new hash, let's create a new hash also. So int new hash is equal to 0. Int new hash, I should say that int new hash is equal to hash. It's not finding hash. let's do not create new hash for now. Okay, let's create new hash now. Okay, so we know that now we have to pattern it traverse from the pattern to the original, right? So we'll have to create a like we have to remove the original one, then have to create a new one, right? So this would be the one I required. Okay, so let me just tell you something. But we did this as well, but let's just convert this into this. ओके, तब भी कुछ फर्क नहीं पड़ेगा। रिटर्न टाइप मांग रहा है डबल में, तो उसे डबल में ही देते हैं फिर रिटर्न टाइप में, तो ठीक है। ओके, ओके, लेट्स क्रिएट द न्यू हैश फंक्शन नाउ। तो एक डबल न्यू हैश बनाते हैं, डबल न्यू हैश। अच्छा, डबल न्यू हैश करेगा क्या? डबल न्यू हैश बनेगा किसका? तो ये बनेगा आपका प्रेव हैश, यू नो किसी पर्टिकुलर स्ट्रिंग का बनाते हैं, इसे पैटर्न का नहीं बनाते हैं। ऑलराइट, यस, स्ट्रिंग लेंथ पैटर्न एंड स्ट्रिंग लेंथ पैटर्न, ठीक है। किसी पर्टिकुलर स्ट्रिंग का बनाते हैं इसे, एंड इसको में थोड़े चेंजेस करते हैं, इसे थोड़ा और बढ़िया बनाते हैं, इसे थोड़ा और बढ़िया बनाते हैं। इसमें डालते हैं जो प्रीवियस हैश मेरा आ रहा है, जो मेरा पुराना करेक्टर अब गया था, जो मेरा नया करेक्टर अब आएगा, और मेरी पैटर्न लेंथ, पैटर्न की लेंथ, वेरी इंपॉर्टेंट। अब देखो, प्रीवियस न्यू हैश क्या बनेगा मेरे हिसाब से? जो प्रीवियस हैश मेरा गया है उसमें से ओल्ड कैरेक्टर को माइनस कर दो, ओल्ड कैरेक्टर को माइनस कर दो और डिवाइड कर दो प्राइम से या अपनी हैश की से, जो हमने हैश की बनाई थी। तो न्यू हैश क्या हो जाएगा? न्यू हैश इनटू पैटर्न लेंथ, न्यू हैश इज इक्वल टू प्लस, ये गलत है। ओके, न्यू हैश इज इक्वल टू न्यू कैर इनटू मैथ डॉट पाओ हैश की डॉट पैटर्न लेंथ, पैटर्न लेंथ में से कितना? -1, ये न्यू हैश हो जाएगी, एंड देन रिटर्न इंट न्यू हैश। इसे भी इंट हटाओ, इंट की जरूरत नहीं है, इसे भी डबल में डालते हैं। ऑलराइट, अब एक नया फंक्शन बनाते हैं। अब हमने दोनों वैल्यूज निकाल ली, अब हम करेंगे सर्चिंग। सो सर्चिंग करने के लिए पब्लिक वॉइड सर्च, सर्च फंक्शन क्या लेगा ये आपका? सर्च फंक्शन आपकी दो ही चीज लेगा, एक जो टेक्स्ट आ रहा है और एक जो पैटर्न आपके पास है ऑलरेडी। तो सर्च आपको इनमें ही करना है। तो अब हम यूज करेंगे वो सब चीजें जो हमने ऑलरेडी यहाँ पे लिख रखी है। पैटर्न लेंथ नहीं लिखी है यहाँ पे, पैटर्न 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 नहीं, पैटर्न, पैटर्न। ओके, तो इन पैटर्न लेंथ इज इक्वल टू लेंथ डॉट पैटर्न लेंथ, इन टेक्स्ट लेंथ इक्वल टेक्स्ट डॉट लेंथ। अब चेक करते हैं, तो हैश कोड, सो डबल, क्योंकि हमें पहला हैश की बनाना है, पहली हैश की बनानी है, तो डबल ऑफ टेक्स्ट हैश इज इक्वल टू हैश कोड, हैश कोड, और कहाँ तक चलना है हमें? टेक्स्ट डॉट सबस्ट्रिंग, सबस्ट्रिंग कहाँ तक चलना है? 0 से लेके पैटर्न लेंथ। ये हमारी पहली हैश हो जाएगी। अब हम चेक करेंगे इसके अंदर कि क्या ये मेरी वैल्यू एग्जिस्ट भी करती है या नहीं। एंड फॉर दिस वी विल डू टेक्स्ट लेंथ तक जाएंगे, लेकिन टेक्स्ट लेंथ मुझे पूरा चाहिए। टेक्स्ट लेंथ प्लस मैं ये भी जानता हूं कि मेरी टेक्स्ट लेंथ तक वैल्यू तो नहीं जाएगी, तो यहाँ पे मेरी आएगी पैटर्न लेंथ। ऑलराइट, तो अगर मेरी टेक्स्ट हैश इज इक्वल टू किसकी, पैटर्न हैश नहीं बनाया हमने, पैटर्न हैश, पैटर्न हैश, सो ये बनेगा हमारा पैटर्न हैश। ओके, पैटर्न हैश कहाँ तक जाएगा, 0 से लेके पैटर्न लेंथ -1, या फिर इसे पैटर्न पैटर्न हैश पूरी बनानी है ना, तो सबस्ट्रिंग लेने की जरूरत ही नहीं है, पूरा पैटर्न का ही बनेगा ये तो हमें ये पैटर्न की बनाती है, हमने इतना तो बना ही लिया था। ओके, तो अगर ये मेरी पैटर्न हैश के बराबर है, तो अब आपको चेक करना है कि क्या ये एक एक चीज के बराबर है या नहीं है। तो उसके लिए इफ टेक्स्ट डॉट सबस्ट्रिंग I plus pattern dot length is equals to pattern, then what, then साउट कर दो कि पैटर्न फाउंड एट इंडेक्स आई। बट अगर ऐसा नहीं होता, अगर आप नाकामयाब रहे इस केस में कि यू नो इफ यू आर नॉट अनेबल टू फाइंड दिस, कि हमें नहीं मिल पा रहा, तो उस केस में हमें क्या करना है कि इफ आई इज लेस देन टेक्स्ट लेंथ माइनस पैटर्न लेंथ, देन टेक्स्ट हैश की जो नई कोड आएगी वो हैश कोड नहीं होगी, वो होगी न्यू हैश। न्यू हैश क्या वैल्यू, क्या क्या नाम था, स्लाइडिंग विंडो हैश, सॉरी खुद ही भूल गया, स्लाइडिंग विंडो हैश। तो टेक्स्ट सबस्ट्रिंग तक जाएगा ये। इसके अंदर कितनी क्या पैरामीटर्स थे, लेट्स सी, इसके अंदर क्या पैरामीटर्स थे। ओके ओके, स्लाइडिंग विंडो हैश, स्लाइडिंग विंडो हैश में सबसे पहले आएगी हमारी टेक्स्ट हैश, डबल हैश जो हमारी प्रीवियस हैश थी, और करेक्टर जो ओल्ड हमारा जस्ट अभी गया है, तो करेक्टर ओल्ड कौन सा गया है हमारा, जो हमारा गया है टेक्स्ट डॉट कैरेट आई, ये हमारी ओल्ड वैल्यू थी। कैन नॉट फाइंड लोकल वेरिएबल, अच्छा ओके, वो ये थी इसलिए। टेक्स्ट हैश टेक्स्ट डॉट कैरेक्टर एट आई, और क्या चाहिए मुझे, टेक्स्ट डॉट जो मेरी अब वैल्यू आएगी, आई प्लस पैटर्न लेंथ और मेरी पैटर्न लेंथ, तो ये मेरी वो आ गई वैल्यू। ओके, तो ये मेरी वैल्यू खत्म हो गई यहाँ से। अब मैं अपनी मेन कोड के अंदर जाता हूँ और मैं मेन कोड में सर्च करता हूँ दैट यू नो व्हाट, प्लीज हेल्प मी फाइंड दैट रेवन कार्प एल्गोरिथम, नॉट सर्च, एंड टेक्स्ट होगा मेरा मान लीजिए जॉब, एंड यू नो वी वर डूइंग हेल्प मी फाइंड अ जॉब। ओके, oh sorry, um, so this is what going to be this, and this is this. Okay, let's see. All right, ये रन नहीं करा, string text और string pattern, yeah Macarena, no don't you worry about my boyfriend, and he will ask me Corino. Don't you worry about my boyfriend, and he will ask me Corino. I don't want him, couldn't stand him. What is the problem here? What is the problem here? Why is it not running? It should run, but it's not running. Okay, why? It's giving me error of warning. Where? Why? Here. Okay, let's see the warnings. Let's see the warnings. Unused import statement. Why? Oh, it's a private function. That's why. Private function. Okay, okay, okay. All right. And all right. Okay. Okay, so it's not printing it. Why is it not printing it? Hmm. Okay, sliding window, previous hash, prev hash. What is the value? What is the problem getting in prev hash here? Prev hash is getting me I. It is the previous hash value. Hmm. Let's see. Let's see why is it failing. Okay. Let's see it. Let's run this. Okay. Let's run this. Okay. We'll find out. Pattern length and text 14. Okay. तो हमें तब तक चलना है इसे. So if we find this, then we have pattern hash and then we have text hash. Okay. So double text hash is equal to 0 dot pattern length, and then we have hash code of pattern and hash code of this. Okay. So we have all these things and text and this is we are using text length here. Text dot length here. It's useless here. Oh, all right, all right, all right. All right. So text length here, then pattern length here. Okay. So text is what help me find a what job, and then text hash is this. Okay. So hash code of 0 to pattern length. Okay. Okay. Then text length minus pattern length. Okay. If text hash is equal to pattern hash, no, it's not. 74836 If text hash is equal to pattern hash, then you know what? You can if text then text length then text dot hash is sliding window वाला hash. तो वापस गया है उसके अंदर स्लाइडिंग विंडो वाले हैश को स्लाइडिंग विंडो कॉल ही नहीं करा एक बार भी हमने. ये भी पब्लिक करना है ना यार. So pattern is found at index 11. HE1, okay. Index 11, okay. Index 11. So 12 मिलना चाहिए मुझे. एक दो तीन चार पाँच छः सात आठ नौ 10 11 12. तो इंडेक्स 11 में मिली मुझे. ऑलराइट. सो गुड. गुड. मजे आ गए. ओके. So this is how Raven Cup works. Okay. Let's see some questions. Although we did this, so congratulations, you now have learned a new algorithm called car pyramid. All right. Okay. Let's see a lead code problem. Okay. Let's leave this for now for DNA matching lead code. Okay. So this question is also good. Okay. So this question is telling you that for DNA sequence is composed of strings of nucleotides abbreviated as ACGT. For example, ACGAA, DCTTCG is a DNA sequence. When studying the DNA, it is useful to identify repeated sequences within the DNA. Given a string S that represents the DNA sequence, return all the 10 letter long sequences, substrings that occur more than once in a DNA molecule. You may return the answer in any order. Given a string S that represents a DNA sequence, return all the 10 letter long sequences, substrings that occur more than once in a DNA molecule. You may return the answer in any order. Okay. Okay. All right. So this is a pure Raven-Karp algorithm. Yep. This is a Raven-Karp algorithm. Let's see this. Okay. Let's see this code and then we'll move to Boyer-Moore algorithm, and then last we will do this. Okay. So let's do this. Okay. What this question is actually asking us, can you see? It is telling us that, for example, that there's given a DNA sequence. Okay. So in this DNA sequence, you have to find 10 letter sequences. So the 10 letter is what? So here the pattern length. So now the question is, what will you actually search or find in the pattern length? Okay. So there's no pattern length here. No, but you're wrong. The first pattern length, the actual pattern length is going to be from string indexes from 0 to 10. This is the first pattern length. Okay. And string length is from S to S length. So it's 1 to 10 to the power 5. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So you have to return what DNA sequence? Given a string S, you return all the 10 letter long sequences or substrings. Return all the 10 letter long sequences, substrings that occur more than once in a DNA molecule. The answer in only clue. Okay. So if, okay, so there is a base case here. So the base case is what? That if S dot length is less than 10, 11, very, then just return, you know what? Return S. Return, uh, uh, okay. Return new array list, and just add s in there. I'll add s in there, but this is a base case. I just want to write base case here. Base case. All right. Second case here is how going to find this value. Okay, so the first pattern is going to be from string indexes to 0 to 10, and then you're going to find all the cases from 0 to 10. Okay, so this is a complete copy paste question here. Okay, this is a complete copy paste question here. Let me just do all this. Okay, this is everything you have to need. Okay, now you will say that Lakshay, what about pattern length here? Okay, there's no pattern length here. So there is a pattern length here, and I'll tell you that if it is returned to what, then you have to I'll create a new list as well. Okay, so I'll create a new list as well. Okay, so list, where should we add the list here? Okay, so return, I have to create a new list. So the new list pattern, okay, so S pattern. So string pattern I have to do. So string pattern is equal to do what? Is equal to S dot substring, is equal to S dot substring, and 0 to 10, 0 to 0 to 9, 0 to 9. Okay, 0 to 9. Okay, S dot substring 0 to 9 indexes, that will be your first pattern, and you have to find all these patterns inside it. Okay, so this is what the case is here. Okay, let me just put this inside this. Okay, and you have to since find the DNA sequences inside of it, you have the hash key here. Now you have to actually fill all the values inside the array list. Okay, so once you find all the indices that would have the same here, now you don't need this particular thing. Now you don't need this particular thing. Why? Because you don't need actual substrings. Okay, this is the main thing I'm telling you. So you have string pattern, then you have string text. Okay, you don't need string pattern. But the case is, what about the return a string that represents that occur more than, return all that occur more than once in a DNA molecule. You're studying DNA, it is useful to identify sequences in the DNA. Given a string that represent DNA sequence, you may return all the 10 letter long sequences substrings that occur more than once in a DNA molecule. You may return the answer in any order. Okay, okay. Hmm. Hmm. Okay, this is what I'm thinking. Take a pattern length of 10, this pattern length of 10, store it somewhere in a map or somewhere on an array list. New array list, new hash, new hash, new hash, 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 hash. Every indexes is going to be what? The previous indexes plus one. So after checking everything, if you have same sequences, okay, same sequences, then add them inside that particular thing, only the same ones. Okay, and if not, then you are going to be in the same thing. So we are going to make a little change here. let me just let me just use something here. Okay, let's make a new file. Okay, let's make a new file. We don't have this file already with us, so let's make a new file on this. Okay, on the strings, yep, in Java class. Let's make a new file. We called it DNA sequence. DNA sequence. Okay, let's call it DNA sequence. Yes, add the following file to it. Okay, let's do the DNA sequence. Okay, so yeah. Oh, we have so many questions till now. And let's add Boyle-Moore algorithm as well. Boyle-Moore algorithm. Okay, we'll do this after this. This is useless here. मैं बनाऊंगा इसे बढ़िया सा, एक सेकंड रुक जाओ मुझे. Okay, this. All right. Yep. Oh wow. Okay. All right. Mm-hmm. Hmm. And all right. So we have PSVM. All right. And we have to do south of find static public find repeated subsequences and all those things, and yep, this. All right. Okay. Now, okay, I'll tell you something. Hash set और hash map, मुझे तो केवल यूनिक की वैल्यू चाहिए ना हमेशा. सो अगर मैंने वो वैल्यू ऑलरेडी देख रखी है, then I am to just add in this, and then particular मेरे पास है वैल्यू, so I'll use a hash set of string set. Okay, now understand with me, and also result set, very important. डालेंगे किसमें? And let's name it called res. All right, res. And okay, let's call our famous function. It is called public private final int uh, hash key is equal to 101. All right, all right. Hmm? Okay, all right. And we have this, so we'll just do this. All right, हमें केवल 10 तक ही चाहिए. Okay, first key, first is equal to str dot length, and then we have s dot length. We need to just do for 10, only 10, 0 to 10, or maybe 9, or 9, no 10. Hmm. str, not str, s dot caret I, and hash is going to be what, first, and it's going to be what, first, and hash key is giving me problem, non-static field. Hash key cannot be referenced from make static one hash key, public static final int key. Okay, so we have this. Okay, we have this finally. So we have created the first hash key out of it. This is very important, very very important, very 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 important. Okay, now after we did this, now we have to create a rolling hash, so that it will be creating every time. For that, how do we do that? How do we do that? For that, we will create another function. Let's name that function, that we call it static public double, and let's call it find string by then. And let's do something. Okay, we have to do so many parameters in this. Okay, let's not call recursion here. I don't think recursion would be very fruitful. Okay, so double first is equal to this. All right, we'll name this rolling hash. Okay, we'll name this rolling hash. All right. Now you would be asking what would be returning his, what will be returning here. So we'll be returning this particular thing exactly. Okay. So we'll be having this double of prevalence and all those things. Okay. So you will be doing this. Yes, exactly what we're going to do here. And let me just delete this. And okay. Yep. Hmm. All right. So it worked very smoothly. And now for the final touch, we will be creating another function. We will name this static public double. We will name this, let's make this a void function, okay? Because we have to search everything, right? So we have to create a void function, and let's name this search. and this will only create and this will only have this particular thing that is called string of str string of s. All right, all right. Now for this here, I will create a hash. The hash set will now be valuable here, so we'll do the hash set here. We'll add the rest string here. Now we have all these things here with us. So now let's create the hash set searching one. So for this we have what we have. Okay, so we have double. No. We have int n is equal to s dot length. All right. Now the thing here is, if you can see that we have to match that if these are equal to this. So we're just going to continue with this. Okay. This is nothing rocket science here. We already studied this. Okay. So we're just going to like copy paste this entirely. Yep. And we're just going to change some things. Okay. For example, the pattern length is what? String s and string first. Okay. So pattern length is what? It is string first. Text length is what? It's what? N and text hash. So we haven't created a text hash also. Okay, we were stupid. So text hash is going to be what? So text hash, no, int text hash. Oh, double text hash. Double text hash. Okay, double text hash. क्या टेक्स्ट हैश ही कर देते हैं, जो भी ऑलरेडी है उसे है, ठीक है, इज इक्वल टू रोलिंग हैश dot first dot caret o s dot caret o s dot caret minus one and all those things. So no, I don't think this is good. So first, the previous hash is going to be the first hash or the hash code. First hash, the previous hash, which is the first one. Yep, double first. Huh. And what we're going to remove this s dot caret o, we will name this the previous character that we have defined. Okay, so that we have just removed out of it. Okay, so yeah, I don't, yeah, hash code, we need hash code, not hash key. And what was this? Okay, so we haven't created any type of function here, so let's do what, let's remove this as well, and let's create another function that is called static uh, public hash code hash code and string str. Okay, static public double. Okay, and just copy paste this entirely. This is the only thing you need. All right, now you need hash codes here. Okay, so in order to need hash codes, you will require hash codes. So hash code will require the first thing. So text hash of first code would be what? So it will be s dot substring, and it will be 0 to 0 to 0 to, and then you know what, 0 to 9. All right. Okay, but what about pattern hash? Okay, so we'll have to create a pattern hash as well. So if, so set dot add, no, double text hash. Okay, So if you have seen this particular type of string, the value of text hash in this, so you know what you can do. You have to change the map here. So change of map would be double, double. Now you can add this. Okay. Now you can add set dot add, set dot add, and you will add text hash in there. All right. So this is the first text hash. All right. Okay. Let's see here. Yeah, yeah, you know. All right. Mm. Remove this. Now the only problem that we are facing here, first of all, rolling hash, rolling hash. Okay. Now the only problem that we are facing here in this question is how do we resolve this pattern hash here, because this pattern hash is very important. Okay. But how are we going to match this pattern hash? Okay. The only thing that you can match a pattern hash is because the pattern hash is equal to this. So even if you say that, you know what, let's take it like pattern hash. Okay, let's take it, you know what, let's take it pattern hash, the original pattern hash. Now you will be asking that what would the text hash then let's try to make text hash. Then text hash is equal to hash code of first. Hash code of first would be the text hash. No, 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 no. Hash code of text hash is going to be s dot substring. See what we were doing here, substring of 0 to pattern length. Okay, so we will be doing this of this as well. Okay, so we will be going s dot substring of 0 to um, 9. Now if n minus and first, so first is nothing but we have to know it what pattern hash. So we'll be doing what, n minus 10, 10, yep, 10, yep, 10. If text hash is equal to pattern hash, um, if set if set does not contain it, if set dot does not contains text hash, then rest dot add substring 1 to n. Okay, this is what we were doing. All right, and yep. Now if text length is minus pattern length, so text length is what, n, and pattern length is what, 10. Okay, so if text hash is equal to rolling hash text dot char at I, text dot char at I, so it's not text hash, it's called s dot char at I, s dot char at j, pattern length plus 10, and then pattern length which is 10. Okay, all right. And we haven't called anything, so let's call it. So we shall call it हमने text hash के अंदर value डाल दी, public string void. Okay, so list node result is equal to search and s comma s comma, and we have to add the string first. String first is useless here, so we'll just add this. So we'll add string first as well. All right, and return result. Okay, let's see. Empty string. Wow, beautiful. कुछ प्रॉब्लम्स थी यार, तो मेरा दिमाग खराब हो रहा है, तो मैंने चेक ठीक करवा लिया ऑनलाइन। इसने क्या करके दिया यार, शिट। क्या बना दिया इस कुत्ते ने। विंडो साइज 10 if is equal to return searches, ओके। हैश कोड का फॉर्मूला क्या बनाया है इसने। ओके, एच डॉट कैर टाइप मैच डॉट पावर, हाँ ठीक है, बिल्कुल ठीक है। फिर रोलिंग हैश बनाया, रिमूव द ओल्ड कैर है, हैश माइनस ओल्ड के, शिफ्ट एवरीथिंग डाउन हैश की हाईएस्ट नंबर, डबल न्यू हैश का प्रीवियस में न्यू हैश इज इक्वल टू न्यू हैश, ओके, रिटर्न न्यू हैश, ओके, काम कर रहा है, ये भी काम कर रहा है। ओके, सेट डबल है सीन हैशेस जो अब तक हमने देख लिए हैं, और सेट रिपीट हैशेस, यूज अ सेट टू अवॉइड एडिंग द सेम रिपीट थ्राइस। int 10 is equal to 10, double current hash is equal to hash dot code says dot substring 0 to window size current hash, scene hash is current hash, okay, for I से लेके 1 से लेके window dot size n तक, char old char is equal to s dot char at I minus 1 old dot char, current new char is equal to just char at I, okay, current hash is equal to rolling hash current hash old char new char, and if scene hashes contains the current hash repeated uh, strings dot add substring, else scene hashes not current hash, return new array list, okay, okay, beautiful, अच्छा solution है। ऑलराइट, यहाँ पे हमें वो दोनों भी लेने पड़ेंगे, these two values। आउटपुट क्या दे रहा है ये, ए सी 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 ए सी 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 ए क्या दे रहा है ये, ए सी 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 ये दो वैल्यू हटवाने को कह रहा है, ये दो वैल्यू हटाओ। कौन सी है, ए सी 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 ए सी 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 ए, चार ए और चार ए, ये तो ये हटवा क्यों रहा है इन्हें। देखना हम कहाँ 42 लाइन का कोड लिख रहे थे यार। गाइस आज के लिए खत्म करते हैं यार, मेरा बिल्कुल मन नहीं है अब करने का। ओके, थैंक यू ऑल फॉर वॉचिंग एंड या आई होप यू ऑल गाइस आर गुड। चलो बॉयल मोर कर ही लेते हैं यार। ओके, लेट्स स्टडी व्हाट बॉयल मोर इज। बॉयल मोर algorithm. The Boyer-Moore algorithm is an efficient string searching algorithm that finds the occurrences of a pattern within a larger list. Developed by Robert S. Boyer and J. Strother Moore, it is widely considered one of the most efficient, especially for long text string patterns. Unlike many string matching algorithms, Boyer-Moore compares the pattern to the text from right to left. When a mismatch occurs, it efficiently skips large portions of the text by using pre-computed informations or heuristics. This allows the algorithm to often achieve sublinear time complexity in practice, meaning it might examine fewer characters than the total text length. Two main heuristics. The algorithm primarily uses two heuristics to determine how far to shift the pattern after a mismatch. Bad character heuristic. This heuristic considers the character in the text where a mismatch occurred. If this character, if this character is not in the pattern, pattern can be shifted. Pattern can be shifted faster. If the character is in the pattern, the shift line is fixed. Bad character heuristic. Both of the above heuristics can be used to independently search a pattern in a text. But let's first install two independent functions work together in the file. If we look at the naive algorithm, it slides the pattern over the text by one. The KMK algorithm does pre-processing over the pattern so that the pattern can be shifted by more than one. The Boyer-Moore algorithm does pre-processing for the same reason. It processes the pattern and creates different arrays for each of the two heuristics at every step. It slides the pattern by the max of the slides suggested by each of the two heuristics, so it fixes the greatest offset suggested by the heuristics at every step. Unlike previous pattern searching algorithms, the Boyer-Moore algorithm starts matching from the last character of the pattern. In this post, we will discuss the bad character heuristic and the good heuristic in the next post. Bad character heuristic. The idea of a bad character heuristic is very simple. The character of the text which doesn't match with the current character of the pattern is called the bad character. Upon mismatch, we shift the pattern until the mismatch becomes a match. Pattern P moves past the mismatch character. Case 1. Mismatch becomes a match. last occurrence of the mismatched character in the pattern. And if the mismatched character exists in the pattern, then we will shift the pattern such that it becomes aligned to the mismatched character in the text table. Okay. For example, if you have a string like this, okay, and we have a pattern like this. Okay. Hmm.